Hello, once again, very good afternoon. So now we are going to start the numericals. Okay, in last class we learned to how to solve such kind of problem, but today we are going to discuss how this correction will come in calculate. Okay, so there are some reason due to which the length of chain will be changed. Okay, suppose I am saying there is one chain whose length is 30 meter. Okay, so 30 meter will be at some strength. It is this chain is made of steel, so steel will expand when the temperature will be rise. So this chain is having 30-meter length at standard temperature. Or and one more thing, the pull applied during the measurement should be standard. If the pull will be more, that time the material of this chain will expand, and due to which the length of chain will be increased. So there is standard temperature and standard pull. So these two things we should consider. If the pull will be more, that time due to extra force, there will be expansion of steel steel chain, and if temperature will more, so due to raising of temperature the material will expand. That's why temperature should be standard and pull should be standard, but at the time of measurement this value might be changed. So there are some formulas for calculating the expansion or length of correction of chain. So we are going to discuss second one first of all. So correction for extra pull. As we know, formula for elongation of bar due to force, it is FL upon AE. Okay, F is force, L is length of bar, A is cross section area of material, and E is modulus of elasticity or Young's modulus. So similarly, at standard temperature, suppose pull, sorry, standard pull or a standard force is P0 required, but we are applying force P. Suppose a chain is standardized at 20 Newton, but we are applying 30 Newton force. So how much extra is there? So 10 Newton is extra. So for 10 Newton, there will be elongation of bar. It is a standard pull which we have to apply. But actually we have applied 30 Newton. So how much extra? It is 10. That's why P minus P0, here it is the formula, P minus P0 divided by AE. P minus P0, P is applied pull minus P0 is standard pull multiplied by L upon AE. P0 is standard pull, P is pull applied, A is cross section area of the tape, and L is measured length. Okay, and E is Young's modulus or modulus of elasticity of material. So that much correction is required. Okay. Second thing is temperature correction. This suppose T0 is standard temperature. Okay, so alpha is there. Alpha is coefficient of thermal expansion. So alpha delta LT. This formula is, I think you have learned this formula in 10th class. Okay, alpha delta T L. Okay, this is the elongation of bar due to temperature rise. So temperature initial standard temperature is T0 and working temperature is Tm. So alpha delta TL. Okay, this is the expansion of bar due to chain due to temperature change. Okay. Third is correction for slope. Suppose we are calculating distance at sloping ground at an angle of theta. So correction will be L1 minus cos theta. Okay, this is the correction. And due to MSL correction, mean sea level, this correction is for mean sea level. L is L is length of bar, length of chain or distance measured. H is elevation difference between 2 points, and R is radius of curvature of Earth. So these four corrections are there, but these two are important for first year. But we have to memorize these two formula also. So there is one numerical which we are going to solve. Okay. A line is measured with a steel tape. Okay. A line is measured with a steel tape. It is approximately 100 meter long. Calculate the correct length if the line at MSL when the pull at the standardization is 15 kg. Okay. The pull applied is 23 kg. Standard pull is 15 kg. Applied pull is 23 kg. Cross section area of tape is given. This is the cross section area. Modulus elasticity, value of modulus elasticity is also given. E is given, and temperature Tm and T0 are this and this. Okay, this is standard temperature. This is working temperature. The difference in elevation between two ends is r 2 meter. The radius of Earth is given. The elevation line MSL is 100 meter, 1000 meter. Alpha value of coefficient of alpha is coefficient of thermal expansion alpha is given. Calculate the correct length. So first of all, we are going to calculate the temperature correction. So for temperature correction, we are having formula alpha delta T and L. So value of alpha is given. It is how much? 12 into 10 to the power minus 6. Okay, multiply by delta T. So change in temperature is 20 degrees centigrade. Okay, so it is positive. So change in temperature 20. Okay, because initial temperature means standard temperature is this and working temperature is this. So what is the difference? It is plus 20. So temperature is raised by 20 degrees centigrade. And delta T and L, length of the distance measure, it is okay. We are not calculating the correction in chain. Actually, we are at the last, we will multiply it by length of, so directly length of distance. So directly we are applying the correction in distance. So it is 1000. If you want to do it with chain, that time the answer will be same. There it is. So I am writing here 1000. So when you will solve it, you will get the answer. It is 0. Sorry, 0.2400 meter. Okay. Due to rise of temperature, the length of chain was increased. So distance measured distance will be more. So how much more? It is 0.2400 meter. Okay. So it is positive. Second, pull correction. We have applied extra force. How much extra? 15 kg was standard and extra applied was 23. So we have applied extra force. It is 8 kg. So 8 F L F L F L value of L. That first of all, I'm writing the formula FL upon A. Okay, so value of F extra force is 8, L is 1000 divided by A area of cross section. Area of cross section is 0.0645 multiplied by E. Value of E is 2.11 into 10 to the power 10 to the power 6. Is it correct? Yeah. So value of change in length will be 0.0588 meter. Okay. So due to extra force, length of chain will be increased. So ultimately, there will be addition. Means the distance measure will be more. How much more? It will be 0.0588 meter. It is positive. Now slope correction. Correction of slope. Okay. Correction of slope and MSL. So these two correction are always negative. So I'm first of all I'm writing the correction of slope. Correction of slope is equal to h square upon 12. So h is height difference in height, so it is 2 square upon 2 into 1000. So it will be equal to 0.0020 meter is negative. And MSL correction, it is LH upon R. So L length, measure length is this much, and elevation was 1000, and R is 6400. It is in kilometers, so we have converted it into meter. Okay, so it will be 0.15, 0.15, 63 meter. It is also negative. So temperature, full correction, slope correction, and MSL correction. We have learned this thing. I think you understood how to solve the problem and why we are calculating all the things. Okay, so is there any doubt? Please comment. Directly, I am writing here one more formula: h square upon 12. Okay, so in next class we will start the compass survey. Okay, thank you very much for joining the class. Have a nice day.